So let A and B be two non-empty sets, and F is a relation which associates each element of set A with unique element of set B. Then it is called as a function from A to B. So let us consider two sets, set A, set B. In very simple terms, you have some elements here, say X or X1, X1, X2, X3. And set B has say Y1, Y2, Y3. All right. Now, what is the definition of a function? That it's a relation. There are so many types of relations you can make. We'll not go into details. We are just focusing only on what is a function. One such relation is a function. When every element of A is involved in the mapping, all right, like X1 is mapped to Y1, X2 is mapped to Y2, and X3 is mapped to Y2, let us say. Now, and so first part is if F is a relation which associates each element of set A. This is the first part. Every element in set A must be included in the mapping. Second, it is associated with a unique element in set B. That means X1 is mapped only to one element. It cannot happen that you have, X1, X2, X3, Y1, Y2, Y3. You cannot have that X1 is mapping to two elements in set B. If this happens, then it is not a function. Okay, this particular relationship is not a function. Okay, this is a function. All right. So this is a basic that we learned. Now this and also suppose X3 is not involved. Again, it will cease to be a function. So X1, X2, X3 all are involved. So this particular set of A with these elements is called as the domain, and the set B is called as the codomain. This we know. So we write as function that maps set A to set B. All right. Then so now for example here we write here f of x1 is equal to y1, which means that x1 is associated to y1 under this functional relationship. Okay, f of x1 is equal to y1. So this y1 is called as the image. It is called as the image of x1 under F. And x1 is called as the pre-image of y1 under F. All right. So here I have given this example and I'm showing here, but here it is said like that. If A belongs to set A is associated with B belonging to set B, then B is called the image of A under F and is denoted as F of A equal to B, and A is called as the pre-image or inverse image of B, as denoted as F inverse of B is equal to A, such that F of A is equal to B. All right. Now, an element of B can have more than one pre-images. Acha, very important part. These concepts can come in your general aptitude. It may not directly come in your engineering maths, combined with permutation combination. So when we come to that, I will give some examples and show how these concepts will come. So look here. This y2 is an element in B. What are its pre-images? X2 and X3. These are the pre-images of y2. So elements in B can have more than one pre-images. Okay. But elements in A cannot have more than one images. That is the important part. Next, what is range? Range is set of all the images. Set of all the images is called as the range. So here in this particular function, we see that the codomain has y1, y2, y3, but the number of elements, the elements that are occurring as images are only y1 and y2. So the range of F is y1, y2. So the domain A is x1, x2, x3. The codomain B is y1, y2, y3. But range is y1, y2. All right. And we denote range like this. F of A is f of x for all such that x belongs to A. So all the values of function, all the values of f of x put together gives you the range. Okay, this is a basic that we have learned. Now there is a representation of functions. How do you represent functions? And there are different types of functional representations. So in set form, the functions are represented as set of ordered pairs like this. 1, 2, 2, 4, 3, 1, 4, 3. In the example that we have taken here, all right, we can write the function as f is equal to, in this example, what will be f? It will be x1, y1, x2, y2, x3, y2. This is the function as the set of ordered pairs. All right. Now this is easy as long as it is a discrete. Your domain and range are discrete for discrete sets. This is a valid representation. But for continuous sets, that means your domain is a continuous set of real numbers. Like your domain is 0 to 10, set of all real numbers between 0 and 10. Now you cannot keep writing how many numbers are there between 0 and 10. Infinite number of real numbers, and it is impossible to represent using this set form. So that is why there is an algebraic relation form. So we write function as, an expression, an algebraic expression. Y is your value within the codomain, is a function of x, and it has certain expression. Here we have taken x plus 1. This is an expression. And all the while we deal with functions with these expressions. So the functions can be, most of the times we deal with functional expressions like this. I'm just said algebraic relation. It need not be an algebraic relation. It can be trigonometric, logarithmic, exponential. So all the transcendental functions that which are not algebraic, they have a functional representation. And each of the function, both set of ordered pairs as well as algebraic, they can be represented on a graph. So very important to understand, because graphical understanding is extremely important in calculus. So let's do that. Just a second. So what is a graphical representation of a function? On the horizontal axis or the x-axis, we plot the domain. All right. And on y, we plot the codomain. All right. Now we had, x1, x2, x3, y1, y2, y3, discrete. Okay, the discrete graph. Now when you plot the graph, x1 is related to y1. So this particular point represent your functional relationship f. Then x2 relates to y2, and x3 in our example also relates to y2. So this is a representation of the function. This is a function. Of course, it's a function which is breaking. It is not a continuous curve. Now let us plot this function now. Y is equal to x plus 1. Right? We know what it is. It is a straight line. Just a second. Yeah, it's a straight line. So this is the graph. So it is a continuous set of infinite points which lie on this particular line. This is your functional expression. So function is expressed also as a graph. So at any point, say, so at x equal to 2, the value of y is 3. So now at 1.5, it will be 2.5. And at 2.99, the function value will be 3.99. So it is set of all values of x comma y which satisfy this particular equation. So this is a graphical representation of a function.